Before I get into simplifying radicals, I want to talk about what is meant by a perfect square. So if I say, what is the square root of 4? It means what number times itself equals 4, and that's going to be 2. What number times itself is 9, and that's going to be 3. So that's what is meant by a perfect square. So if I use the breaking down method of factoring 9 and breaking it down into its prime factors, what happens is that I have the same number twice. And so basically what I'm saying is what number times itself gives me 9? Well, it's 3 times 3. So that's why when I have a pair, it comes out as 1. So let's think about that again. If I said what number times itself is 16, you know the answer is 4, because if I break it down to 4 and 4, which you can break down further, but I just want to show you, if I break it down to 4 and 4, the square root of 16 is just one of those 4s. So it takes pairs to come out as 1. Okay, so every pair comes out of the square root as itself one time, and then so you only write it once on the outside of the radical, it comes out. Okay, and anything, for example, if I had something like the square root of 8. So let's try this. So we're going to break down 8 to 4 and 2. I only circle the prime factors, so I only circle 2. Then I break down 4, and I get another 2 times 2, and I'm done because those three numbers, the circled numbers, multiply to give me 8. But now I look for pairs because the way a square root is for every pair, 1 comes out, because this is like saying what is the square root of 4, which we know is 2. So for every pair, 1 number comes out of the radical. Then I write the radical, and if anything is left, I put that inside. So the answer is 2 radical 2. So let's try a couple more, like the square root of 24. So let's break it down. Maybe you would do 4 and 6. I don't circle them because they're not prime. Then I get 2 and 2. I circle those. And then from the 6, I get 2 and 3, and I circle those. And now I look for a pair. Okay, this pair is going to come out as 1, and I write the radical. Now, what's remaining cannot come out because for every 2, you need 2 to get out of that radical. So they go back in together as 2 times 6, and that's the answer. All right, I'd like to try another one. Let's do, how about the square root of 18? So you might do 6 and 3, you could do 9 and 2, it doesn't matter. But whichever I do, there's the prime, and then 3 times 3, there's the other prime. And again, I'm looking for pairs. There's only one pair. So when I write the radical, the pair comes on the outside as 1, the singleton stays inside. That's how you do it. So let's try something like the square root of 72, something a little bit bigger. Okay, so if it's even, just divide by 2. And I'm just going to continue dividing by 2 because it's continue to be even. And we just had 18, so we know that's 3 and 3. Okay, so I'm going to look for pairs. I see a pair of 2's here, and I see a pair of 3's here. Okay, so let me write my radical. This pair of 2's is going to come out as a 2, and this pair of 3's is going to come out as a 3, and then this 2 goes back in. I multiply those numbers. I get 6 radical 2. That's the answer. Okay, just a couple more. So if you have something like the square root of 10, for example. Well, when I break that down, I get 2 and 5. Do I see any pairs? No. So I keep them together. I put them back in square root of 10. There's not enough for it to come out of the radical. It stays on the inside. So I am going to give you something to try here. I'm going to give you a few to try, and I want you to pause the video afterwards. So let's do this one. Let's do this one. And let's do this one. Okay, so I'd like you to try those 3, pause the video, and we'll see if you're right, and then start it again, and I'll go over it. So for 48, I know that's 2 times 24. That is 2 times 12, 2 times 6, 2 times 3. I look for my pairs. 2 sets of 2. So on the outside, I get a 2, 1, 2 from here, 1, 2 from here. I multiply, and the 3 is a singleton. He stays under. So that answer is 4 radical 3. I hope you got that. Okay, I just realized that the square root of 100 should have been very easy for you. No work required. That's equal to 10 because the square root of 10 times 10 is 100. So that's a pair that's going to come out as 1. And with this one, let's divide 2 into 74, and I get 37. They are both prime. Nothing can divide into 37, so I put them back in, and I just get the square root of 74. There's nothing more that you can do with that one. All right, let's just try one last one to really make sure that you've got this, and then hopefully you're good to go. Let's try the square root of 27. So pause the video and try that one, please. And hopefully you got that that was 3 times 9, which is then 3 and 3. So I have one pair of 3s, whichever pair you choose, that goes outside, and then the singleton stays inside. So I hope that you understand a little bit more about radicals now.